So today we're going to be talking about what is it? Stoichiometry calculations based on balanced chemical equations, right? So normally what we mean when we refer to stoichiometry is that it's the calculation of the quantities of reactants and products in a chemical reaction. So let us just start with this question over here. It says that what mass of iron 2 sulfide is formed when 5.6 gram of iron is completely reacted with sulfur. So we have this, they gave us this chemical reaction. It's balanced because there's one iron this side, one iron this side, and here we have iron sulfide this side, one sulfur that side. So what is this chemical equation telling us? That if we had 1 mole, for 1 mole of iron, we will also need 1 mole of sulfur, which will yield 1 mole of iron sulfide. So essentially, we have to start with what we know. So we know the mass of iron, and we want the mass of iron sulfide. So we have to check the ratio of what we know to the ratio of what is it that we're looking for. So the ratio of iron to iron sulfide is 1:1. So if we had 1 mole of iron sulfide, we'll have a 1 mole of iron. Ooh. If we had 1 mole of iron, we will have 1 mole of iron sulfide. So now let us actually calculate the actual moles of iron in this reaction. And we can do that simply by saying N, so NFE equals to the mass of Fe, which we are given, plus the molar mass of Fe. You can find the molar mass of Fe on your periodic table. So that will be 5.6 grams, all divided by 55.8. We don't need to write these grams here. 55.8, is it 55? Yeah, 55.8. And you find this value to be equals to 0.1 mole, right? So now we have found that the value of the number of moles of Fe, so we found that the number of moles of Fe equals to 0.1 mole. So if the ratio of Fe to FeS or iron sulfide is 1:1, it means that the number of moles of iron sulfide will also be 0.1 mole, because the ratio is 1:1. Cool. So if you now have the number of moles of iron sulfide, it's just a matter of now finding the mass. To find the mass, which is simple, the mass of iron sulfide equals to the number of moles of Fe. So this is, I've just reworked this formula here and made M my subject. So meaning M will be equals to M times N. So the number of moles of iron sulfide multiplied by the molar mass of iron sulfide. So how do we find the molar mass of iron sulfide? We find that mass by just saying, okay, so the mass of iron sulfide, molar mass, is going to be iron is 55.8 plus the value for sulfur in our periodic table. Let me quickly look for it. It is 28, and this is going to give us close to 87.8, right? So meaning the mass of FeS will be 0.1 multiplied by 87.8, which will give us 8.79 grams. So that's how you would normally use stoichiometry to determine either the mass or the quantities of the reactants or the quantities of your product given a certain information about one of them, right? So let us do another example. So we have another question over here, and it says to us, barium chloride and sulfuric acid react according to the following reaction. So they've given us the reaction. It's already balanced, but it's often very important to make sure that it is balanced. Otherwise, you're going to get the wrong values. Cool. And then to produce barium sulfate, so barium chloride reacts with sulfuric acid to produce barium sulfate and hydrochloric acid, which is HCl, right? And then if you have 2 grams of barium chloride, what quantity of whatever is it that you're going to find, you have to report it in grams of sulfuric acid will you need for the reaction so that all the barium chloride is used up. So, like I mentioned, the first step is often to just write the balanced ensure that your chemical equation is balanced. So I'll just write it here again: BaCl2 plus H2SO4 sulfuric acid, barium sulfate plus 2HCl, right? So what is this telling me? So for 1 mole of barium chloride, I will need 1 mole of sulfuric acid, which will produce 1 mole of barium sulfate, which will produce 2 moles of HCl, right? So now I know the information about barium chloride and I'm looking for the information for H2SO4. So meaning I have to compare the ratio of barium chloride to the ratio of what is it that I don't know, which is our sulfuric acid. And we can see that the ratio of it is 1:1:1. For every 1 mole of barium chloride is 1 mole of hydrochloric lying sulfuric acid. Cool. So I know I can find the actual number of moles of barium chloride. So I can say N. Let me remove this. I don't have enough space near me. So I have the number of moles of barium chloride is going to be the mass of barium chloride, which we know they gave it to us and they said it is 2 grams, right? Divided by the molar mass of, so let me not do my shortcuts and end up confusing you. So yeah, the number of moles of barium chloride is going to be the mass of barium chloride divided by the molar mass of barium chloride. So you can find the look at your periodic table. So barium has a molar value. I'm trying to find where it is on my periodic table and I can't actually look for it, find it. Where is barium? So it has a molar mass of 137. So it's 137 plus chlorine has a molar mass of about 35.5. So 137 plus 35.5 times 2 because of its Cl2. And you find that that molar mass to be around 208.2, right? Grams per mole, right? This is going to be at the bottom, and then the mass we've already given to us, it is 2 grams. So if you put this in your calculator, you are supposed to find a value of 0.0096 moles. So if we know so it means that if we know the value of the number of moles of barium chloride, we also know the number of moles of sodium what is this, sulfuric acid, right? Because their ratio is 1:1, meaning also the number of moles of sulfuric acid is going to be 0.0096, right? And now how do we then find the mass? If we find the mass, so we can find the mass of sulfuric acid by saying it is just the product of the number of moles of sulfuric acid multiplied by the molar mass of sulfuric acid, and you should be able to determine it, the number of the molar mass of sulfuric acid. So it's going to be 0.0096 multiplied by the molar, what is it? The molar mass of sulfuric acid is 98,12. So to find it, you're simply going to add the molar mass for hydrogen times 2, the molar mass of sulfur plus the molar mass of oxygen times 4, right? So I'm hoping that you are actually able to do that. Or let me just try to do it. So to find the molar mass, that molar mass there, and sometimes the values will differ sometimes depending on the type of periodic table that you're using. But you know, at the back of your question paper, you're actually given a periodic table. So to find it, we actually say if we assumed that the value of what is it, hydrogen, the molar mass was 1, we multiply it by 2 because it's H2 plus sulfur, let me check, it's 32, I think, plus 16 times. So you can see that I didn't include the decimal numbers. So 16 times 2, which is 1 times 2, you can put this in a calculator, 2 plus 32 plus 32, 32 plus 32 is 64, 64 plus 2 is 66, which, oh, okay, this is 16 times 4. So this is 64, and you're supposed to come to that value of 98. 64 plus 32 plus 2 is going to give you 98 grams per mole. Cool. Which is the same as, more or less the same as 98.12. Just depends on the type of what is it, the type of periodic table you have in front of you, right? So yeah, this actually is the end of that. So I'm hoping that you can see, no, I'm lying, there's actually a question too that I quickly want to do with you. This is the follow-up question. So before we go to that question, I realized that I actually didn't include right the answer. So if you multiply this, you find it is 0.94 grams. So you will need 0.94 grams of sulfuric acid, you know, so that the 2 grams of barium chloride is completely used up. So the follow-up question there was, what mass of hydrochloric acid is produced during the reaction? So let us go back again to our balanced equation. So we know the value for this, the number of moles for this, and we can say that the, what is it? The ratio of barium chloride to HCl is 1 is to 2. So meaning we will have to multiply the number of moles of barium chloride by 2. So to get the number of moles of HCl. So the number of moles of barium chloride, we found it to be 0.09096. We have to multiply it by 2, and we find that value to be 0.0192 moles. And then this is also just the same thing. I don't have enough space. So now to find the mass of HCl, we will simply say it is the number of moles of HCl multiplied by the molar mass of HCl. So that will be, to find the molar mass of HCl, say the molar mass of hydrogen, which is 1, plus the molar mass of chlorine, which is 35.5, right? And then, so we know this to be 0.192 192 multiplied by 36.46. So this is the molar mass of hydrogen chloride or hydrochloric acid, right? And then your value that you're going to find is going to be 0.79 grams. So maybe your molar mass would be slightly different. You'd find, so it's maybe the periodic table you were using gave the value of hydrogen to be 1, and then of chlorine to be 35.5. So this is actually going to give you 36.5. But you can see that these values are closely related to each other. So, you know, in your marking guidelines, they will make an exception for that or an accommodation for that. But the thing is that it depends on the periodic table that you're given at the back of your question paper, right? So use that periodic table. Cool. So let us just finish off this lesson.